So when we solved a linear equation in one variable, we got just a single number. And the normal thing for a linear equation in one variable is that there's just a single solution. There's just one number that we can plug in for the one variable, and that's the only number that makes the equation true. Occasionally, something weird will happen with a linear equation in one variable. And as we go through the solving steps, all the variables will cancel out, and we need to decide how to interpret that. In real life, the interpretation usually is that there's something wrong with the way that we set up our equation in the first place. Because in real life, the kind of problems that we're trying to solve with a linear equation will usually just have the one solution. When we're working with an equation in two variables, things are a little bit more complicated. First of all, in order to have just one solution to an equation in two variables, we need to have two numbers, right? We need to have a value for each variable. And in fact, because what an equation in two variables is telling us is not a really strict limitation on the value of each variable, but rather a relationship between the two values, equations in two variables will typically have, we say, infinitely many solutions. When something has infinitely many solutions, that means that we can come up with as many as we like. We can come up with as many different solutions to an equation in two variables as we want. And that's nice in that it means that we can come up with lots and lots of solutions. But it makes finding any single solution a little bit difficult. So if we want to find some specific solution, we have to pick which one we're going to get. And the way that we do that is to start with, we're going to choose the value for one of the variables. Once we choose a value for one variable, we're going to plug that into the equation. And now our equation only has one variable. We know how to solve an equation in one variable, so we're going to solve that new equation. And sometimes there are choices that we can make that's going to make that new equation super easy to solve. Finally, having solved that new equation, we need a way to present our answer that makes it clear that these two numbers are just one solution. And the form we're going to use for our answer is an ordered pair. So let's see how that works in practice. In this example, we want to find a solution. And notice, we said find a solution, not find the solution, right? If we say find a solution, we know there's more than one. We just want one of them. And we want to find a solution for the equation y equals 2x minus 1. I claim that it is easier to find a solution for this equation by choosing a value of x and then finding the corresponding value of y. I'm going to choose x equals, I'm now picking a number completely at random. I'm going to choose x equals 7. I can choose whatever value of x I want. If I choose a different value of x, I'll get a different answer to this question, but that answer will still be correct. Why does choosing a value of x make this easy? Well, now I'm going to take my equation and plug in that value of x that I just chose. And I see that the form of my equation now is y equals a numeric expression. So to find the value of y, I just need to take that numeric expression and evaluate it. I can do that by hand, or I can just throw it into the calculator. We'll just say 2 times 7 minus 1, and we get y equals 13. Okay. How do we put that solution together? How do we report that solution? Well, the form we're going to give is an ordered pair. So an ordered pair, we have a pair of parentheses and a comma. And then we list the x value first and the y value second. And that's always the case in an ordered pair. So the first number represents the x value, the second number represents the y value. If our variables are not named x and y, our variables will still have some fixed order. If they are named x and y, they'll always be presented x first, y second. If it's not obvious what the order is, we can be very clear by saying that the solution is xy equals 7, 13. Okay, so I said that this is easier if we start by choosing the value of x and then finding the value of y. Why is that? Well, if we started out choosing the value of y, we would get a two-step equation. If we chose, say, y equals 13, we'd get the equation 13 equals 2x minus 1, which is harder to solve, right? This is a two-step equation, so it would require more steps to solve it. Not impossible, we know how. But if we get to make a choice in solving a problem, we should always make the choice that makes our lives easy. In this next example, we'll see how it shakes out if we do need to choose a value of y. Because in example 25, we're asked to find 3 different solutions to this equation. And we're asked to find at least one of them by choosing a value of y. So I'm going to start out. For my first solution, I'm going to choose the value of y. We can just pick any number. I'm going to choose y equals 0. I like to choose 0 because in general, 0 is an easy number to do arithmetic to. So if I choose y equals 0, my equation becomes 0 equals 2/3 x plus 5. And I like having my variable on the left. Equals signs work both ways, so I can just swap the order of this equation. I can instead say 2/3 x plus 5 equals 0. That looks a little bit nicer. It's a two-step equation either way. I like to write the x on the left because that's what I'm used to seeing. All right, next step. We need to get rid of the 5. So we'll subtract 5 on both sides. On the left, we're left with 2/3 x. On the right, we've got -5. And now we need to divide both sides by 2/3. So we'll get x equals -5 divided by 2/3, which I think that's a job for the calculator. We'll say -5 divided by, in parentheses, 2/3. And I'd like this as a fraction, so I'm going to go to Math and choose option 1, Convert to Fraction. I get x is -15 halves. So the first solution we get is the pair x is -15 halves, y is 0. And even though it contains fractions, that's a perfectly legitimate solution for this equation. On the other hand, I'd kind of rather not have fractions in my solutions. For my next two solutions, I get to choose values of x, And I think I'm going to choose values of x so that I do not end up with fractions in my solutions. Let's see how we can do that. I already got a solution where I had y equals 0. Let's see if I can get a solution where I have x equals 0, and if that has fractions in it. Plugging that into my equation, I've got y equals 2/3 times 0 plus 5. Oh, well, 2/3 times 0 is just 0. And then 0 plus 5 is just 5. So that gives me the solution. X is 0, y is 5. And I notice that the reason that I didn't get a fraction in my answer is that 2/3 times 0 was a whole number. What other numbers can I pick that I know that 2/3 times that number is going to be a whole number? Well, I know that I want to get a whole number when I multiply by 2/3. In order to make that happen, I want to multiply something that 3 goes into evenly. In other words, I want to choose a multiple of 3. So that could be 3, 6, 9, 12. Or it could be like -3, -6, -9, -12, and so on. I'm going to choose the easiest one of those. I'm going to choose x equals 3 as my next value. So when we plug that in, y is 2/3 times 3 plus 5. And to work out what that actually is, we can just throw that into the calculator. We'll say 2/3 times 3 plus 5, and that works out to 7. So that gives us the solution x equals 3, y equals 7. So, okay, what were the solutions we found? We found 3 solutions. The first one was -15/2, comma 0. The second one was 0, 5. And the third one was 3, 7. And in each case, the x value is the first entry, and the y value is the second entry.